Imagine traveling hundreds of acres through farmland just to collect a few soil samples. This is the reality that our farmers face. And on top of that, they have to wait weeks to get the soil data back from the lab. The process is labor-intensive, time-consuming, and costly. Because of this, farmers often don't sample their soil, risking crop health. GroundHog is a rover that automates the soil testing process. It uses GPS to navigate through farm rows, probing the soil for pH, moisture, temperature, and electrical conductivity. Hi, my name is Mira G. I'm coming from Winston Churchill Early College. I am the project leader.
My name is Landon Noom. I come from St. John's College High School. I am the mechanical and electrical lead, and I work a bit in software.
Hey, I'm Atarv Dua, and I come from Thomas S. Wooten High School. On the team, I'm going to be working as the data science lead. I'm going to be helping on code. I'm going to be working on electronics, and I'm going to be the lead on web dev.
Hi, my name is Jan Chaudhry. I'm a senior at Wooten High School. For this project, I'm going to be the software lead.
Hi, my name is Josie. I'm from Southern High School, and I'm doing a mix of hardware and software.
We're Team GroundHog.
So GroundHog really aims to solve analysis in farms, especially in local farms. And our rover will go around and probe soil to get meaningful data for the farmers. And then they can use that data to help modify the irrigation systems, their nutrient systems, and other methods of farming.
So we have a sensor that comes down from the middle of the rover, and when it goes in the soil, it has a pH sensor, moisture sensor, temperature sensor, and nutrients. And then it'll store that data, and it'll go to a website where farmers can access graphs and this information.
So just as an itinerary for next week, the hardware team is going to be focusing on CADing structures and making sure everything works. The electronics team is going to be focusing on making sure the microcontrollers are able to control everything. The software team is going to be focusing on the website and all the back-end structures.
I think our goals are pretty ambitious, but we're going to make it happen. So we started working a bit on our CAD design. We have to make a rack and some gears to insert the sensor into the ground. We've sent that in to get 3D printed, so that's some progress we made.
Majority of the website design in the back end has been done. Right now we're waiting for the sensor to come in, so we have to create dummy data to work with, because once the actual supplies come and we get real world data, then it'll be much more seamless, and we won't have to, once we get there, then work on the website.
This week we've done obviously a lot of research and a lot of work. So next week is like implementation of what we've done so far, making sure everything works properly.
Today we got a lot of shipment of a lot of our goods. We have more sensors, including our soil sensors. We also have our rover, and we have all the other boards we need to connect everything. Right now we're having trouble with the soil sensor, but we hope to fix that by the end of this week or beginning of next week.
We originally completed the rack and pinion, but we found once the sensors actually arrived that the documentation on them was quite incorrect. So we have to redo the model substantially. So we've been working on getting that done as fast as we can and starting to work on the actual servos and the wiring layout.
The software side is really coming along, and the website's done, the machine learning model's almost done, the back end's done. So we're really happy with that, and now it's just the hardware side that we're going to pursue next week. And now that the software's done, every single person on the team can help with the hardware. So hopefully that'll get done quickly too.
We got this shipped in around Friday last week. This is the SunFounder's design. It, again, copies the design from Mars rover. It has multiple axes and moves around. Really good design. We think this will be really good for the farmland. If it can tackle Mars, it can tackle a farm.
As I mentioned last week, we've been developing a machine learning model to predict the nitrogen, potassium, phosphorus, and other micronutrients in the soil. So that model has been fully developed now, yay. The Flask API is also developed, but we've also been able to improve the accuracy a lot. We've got the nitrogen capabilities up to 80% accuracy, which is really good in the industry.
I think we've developed a strong team here, and we're working on this really cool project. So yeah, I'm really proud of the process so far, and I think we're gonna go great places.
We've made a lot of improvements on the wiring. It may look a little bit messy, but before it was like much worse. and we have a Wi-Fi antenna connected to the main controller, and that has a pretty long range.
Right here in the front is our gyroscope. If it were to not go straight, if like a rocket's in the way, it'll adjust the motor speed on one side so it equalizes to go straight again, just to make sure that it's going on a clear path and not just going out of where it should go.
Now we're really trying to integrate everything together because we've gotten every part of our project working fine, independently. Now we're having the trouble of putting it all together on one final robot.
On the business and idea validation side, we've received a lot of responses, and 88% of them say that the rover is a really good idea and that they would buy it. I mean, some farmers went up to like 20K. We'd spend $20K on that. It only took us like 500 to make it, so that's really encouraging for us.
I think we've exceeded our own expectations because it all started with these ideas, right? We didn't know how to put them together. Because I remember like Ayan telling me he had this idea and I was like, do you know how to do that? He's like, no, I don't. But we still did it, you know? So yeah, like some people in this team have roles that they have never dealt with before. So we're all learning from each other, and it's just a great process, you know?
Over the past 5 weeks, we built a fully functional soil rover that moves, probes, and collects data. We trained a machine learning model to estimate key nutrients like nitrogen, potassium, and phosphorus, and we created a real-time web dashboard with interactive chemical heat maps.
We're taking the best commercially available technology and integrating it together for the needs of local farmers. We can give farmers the data they need to pinpoint irrigation deficiencies and suggest fertilizer changes, overall providing a better experience in farming.
Better soil,
Smarter farming
stronger future with
with
GroundHog.
GroundHog.
Thank you.